Hi again, everybody. Just wanted to add an important note, an addendum to our last video. Um, we were talking about freezing point depression and boiling point elevation, and I did want to point out that those things can't be done like infinitely. You can't just raise the freezing point or the boiling point to as high or as low as you want. There is a point at which they won't lower or raise anymore. And that's at the point at which the solution becomes saturated. So a saturated solution will have the lowest possible freezing point, and the highest possible boiling point. After you hit saturation, of course, you can't dissolve anymore, so it's not going to have the same effect. It's not going to affect the freezing point or the boiling point anymore. So I did want to add that in. Before we move on to our next concept, and our last concept that will be covered in this unit, which is how to make dilutions. So one important thing that chemists often have to do is to take a solution that is at a current concentration and make other concentrations out of it, usually lower concentrations. And that process is called making a dilution. So dilution is, of course, just changing the concentration of a solution by adding solvent. So by adding, water most often, since that's our universal solvent, we reduce the concentration of the solution. So we dilute it. Remember, dilute means a not very concentrated solution. So if we dilute something, we're going to make it less concentrated. And one thing that chemists often have to figure out is, well, if I have, this much of this concentrated solution, how can I make another amount of a smaller concentration solution? And to do that, we use this equation. M1V1 equals M2V2. Wow, that highlighting didn't really work out. Let's erase that. Try it again. All right, we're going to use this equation. There we go. M1V1 equals M2V2. So that's a capital M, right? So that's molarity, which is moles of solute over liters of solution, right? So that moles per solute over liters of solution. That's our molarity, our measures of concentration. And the V, of course, is volume. And it doesn't matter what unit your volume is in, as long as it cancels out. So because of the liters in our molarity, we're probably going to usually want our volume in liters. So that's just something that we want to keep in mind. We just need our units to cancel. So we probably will want our volume in liters most of the time, since that's the unit that is in molarity. So then we're going to go into solving problems with this, right? Just going through and making dilutions. All right, so here's an example of a problem that we might get with making dilutions. And this is a really realistic example of things that chemists do in the lab all the time. So it says, how many milliliters of an aqueous, which just means in water, 2 molar magnesium sulfate solution must be diluted with water to prepare, that should just be prepare, 100 milliliters of aqueous 0.4 molar magnesium sulfate. So we're starting with a molarity 1 of 2 molar. Of course, it has 3 significant digits, but we don't have to include those right now. And we don't know our starting volume. That's the question. And we're ending with a molarity of 0.4 molar. And we want an ending volume of 100 milliliters. So because we have all of the information but one from our equation, right? M1V1 equals M2V2. Then solving this should be relatively easy and straightforward. We have 3 pieces of information. We're missing 1. We can plug in and solve. So M1 is 2x equals 0.4 times 100. So we're going to then just do our math, right? So we have 2x equals 100 times 0.4 is 40. And we're going to divide both sides by 2 to get rid of that 2. And we have x equals 20. Now this is going to come out in milliliters because our original volume was in milliliters. Remember we said our volumes just needed to match. And so if we started out in milliliters, we're going to end in milliliters. Now, you could have converted those milliliters into liters, but because the question asks how many milliliters, it was easier just not to, so that the answer comes out in milliliters. If you had converted it, it would look like this. M1V1 equals M2V2. We would have 2x equals 0.4 times 0.1, because if we convert 100 milliliters into liters, we're going to divide by 1,000. So it's going to be 0.1. Then we have 2x equals 0.02. Oh, sorry, 0.04. We're going to divide both sides by 2. And we get x equals 0.02 liters because we had converted those milliliters to liters here. But the question asks about milliliters, so we would have to convert that 0.02 liters into milliliters, which means multiplying by 100 or 1,000. So we would move our decimal 3 times and get 20 milliliters. See, same answer that we got when we just left it in milliliters. So as long as your two volumes match, it's okay to just plug them in, whatever unit they happen to be. So now there's a practice problem that you guys should go work. Stop the video, go work it, and then come back and you can watch me work out the solution of that problem.